Hi, good morning. I am Devi Abhirami, Assistant Professor, Department of Mathematics. Today I am going to explain the lecture video about the topic test of hypothesis for small sample test using t-test. Okay, there are different types of test. For example, t-test, z-test, and students ratio test. There are so many tests. Here I am going to use t-test, and my first problem is a sample of 10 students has an average test score of 72. It is mean that the average score is denoted by the symbol x bar and the sample standard deviation is 8, that is S or sigma. We can take the standard deviation as S or sigma, and the test whether the mean score is different from the hypothesized population mean of 75. Hypothesized population is denoted as the symbol mu naught. Mu naught is nothing but the population mean, whereas the population mean for this problem is 75. Okay, we have to compute t-test for this problem. They have given the sample for the 10 students, so my n value is 10. So all the values are given in the problem itself and they are told to calculate the t-test value alone. So we know the formula of t-test formula is x minus mu naught divided by s by root n, which means x is nothing but the mean of that sum. So mean of that problem is 72 and the sample is 10. 10 students are there, therefore n is equal to 10. Mu naught is nothing but the population mean. Population mean is 75 and standard deviation is 8, that is denoted as S. Okay, so I am going to substitute that values in my formula. So I get 72 minus 75 divided by S by root n, that is 8 by root 10. So if I subtracted it, I will get minus 3 divided by, if I divide my denominator, I get the value as 2.53. So finally I am going to divide the numerator, both the numerator and the denominator. So my value is minus 1.19, which means the t value of this problem is minus 1.19. Also we can find the degrees of freedom also. In some of the problems they have asked the degrees of freedom also. So the degrees of freedom for this problem is, the n value is 10. So that is n minus 1 will give you the degrees of freedom. So 10 minus 1 is 9. So 9 is the degrees of freedom for this problem. And the second problem is, a food delivery company claims that its average delivery time in a metropolitan city is 30 minutes or less. To verify this, claim a quality control team randomly selected 16 orders and recorded the delivery time. Delivery time is recorded in the terms of 32 to 30 with the alpha, that is the significance level is 0.05, that is 5% level of significance for this problem. We have to determine whether the true mean delivery time is significantly greater than 30 minutes. Okay, so I am going to test with the right-tailed test. So I am going to formulate the hypothesis. There are two types of hypothesis. One is null hypothesis and other one is alternate hypothesis. Null hypothesis is we can reject if the critical value is greater than or equal to the given value. If it is rejected, then we can accept the alternate hypothesis. So I am going to assume the null hypothesis as H naught. H naught is population mean less than or is equal to 30 minutes and the alternate population is mu greater than 30 minutes. Here the level of significance is 0.05. So the given data are 32, 28, 35, 39, 27, 31 and so on till 30. So to find the sample mean, we have to sum of all the values and we have to divide by the number of values. So if we sum it, we will get the value as 512. Whereas there are sample sizes 16. So I am going to divide it by 16. So my value is 32. Here the standard deviation value is not calculated. So I am going to calculate the standard deviation. In the previous problem it has given directly. So I have taken that value. If it is not given, then we have to calculate the value by using this formula. X is given, x bar is also we know. We have to just subtract from x and we have to square that value. For example, first value is 32. 32 minus 32 is 0. So 0 square is 0. Similarly, we are going to solve this for all the values and we get the final standard deviation value as 212. So the formula for the standard deviation is square root of summation x minus x bar the whole square divided by n minus 1. N minus 1 is nothing but the number of observation is 16. Here 16 minus 1 is 15. That is our degrees of freedom. So I am solving it. I get the value as 3.76. Now I got all the values where I have given the previous problem. Okay. Now I am going to test the hypothesis. For test the hypothesis I am using the t-test formula. T-test formula is x minus mu naught divided by s by root n. So I am going to subtract it the numerator. I get 2, and if I solve the denominator I get 0.94. So my answer is 2.13, which is greater than my critical value. My critical value is 1.753. So we can reject the null hypothesis. What I have already told is if I reject the null hypothesis and we have to accept the alternate hypothesis. At the level of significance, it is sufficient to conclude that the true mean delivery time is just greater than the 30 minutes. So I am conclude that the alternate hypothesis is the conclusion for this given problem. So this is how we have to calculate the null hypothesis and the alternate hypothesis, and we can conclude our solution. Thank you.